As we all know, electricity demand is rising day by day, and future power grids will need to predict, schedule and monitor the power production and consumption to satisfy these needs. When we take the monthly electricity bill, we don't get a clear idea on how the energy was consumed. And when considering automatic control of appliances, it's becoming more popular in the modern world. To tackle these problems, we identified that there is no complete solution in the local context. Therefore, we have introduced Oversight. Oversight is an end-to-end solution that monitors and controls appliances in your residence or office and gives insights about energy usage. Let's take a look at the system architecture of the project, which enables us to tackle the aforementioned problems. To cater the controllability aspect of appliances, we have introduced the OTA power socket. The OTA power socket can be used to remotely control any appliance that is connected to it. The socket is designed to withstand the voltage current ratings of the domestic power supply of 13 amperes and 230 volts. Apart from that, there are some appliances that consume a lot of energy but cannot be simply controlled by switching a smart socket, such as ACs. Therefore, we have introduced Oversight AC controller, which can replace the traditional AC remote controllers, and the connected AC units can be controlled from anywhere through the internet. Next, to give the user insights, the Oversight power monitoring socket is introduced. It has the capabilities of the OTA socket, but additionally an extra feature to measure the power consumption of the loads is added to it. This device can measure voltage, current and active power with approximately 95% accuracy. These are some of the snaps from the development stages of our devices. The smart meter and the load monitoring hardware is included in the system to give the user insights on the total energy footprint. The load monitoring hardware can infer the device level power consumption by looking at the aggregate power and complement the measurements of the power monitoring socket. A reliable forecast on energy usage for the next day or for the next month can be valuable to the users and the utility providers. Therefore, our system employs a learning-based model which produces predictions on energy usage from gathered historical energy-related data. We have trained two models with the time resolutions of daily and 4-hourly data. To train and test the models, the individual household electric power consumption dataset from the University of California was selected. In the daily resolution model, 3 LSTM layers were used to gather temporal patterns. An attention layer was used to represent the best of the LSTM states, and a fully connected layer was used to output the predictions. The best performance achieved for this model was around 16%, which was for a day-ahead prediction. In the 4-hourly model, 3 stacked CNN layers were used to extract salient features from the dataset. Then 3 LSTM layers, a self-attention layer to further extract the temporal patterns, and 2 dense layers to give the prediction output of the model were added. The best performance achieved for this model was around 34%, which was for a day-ahead prediction. Here, the prediction error is higher than the daily model due to the existence of more noise. Finally, the components of the system can be controlled and overlooked through the Oversight monitor. Oversight system was integrated using various Google Cloud Platform services and Firestore databases. Some of the key services are Cloud IoT Core to manage 4 different types of IoT devices, Cloud PubSub to manage communication between those devices and the cloud, Google Cloud Functions and Cloud Data Flow to control data flow inside the cloud architecture, BigQuery tables to store historical telemetry data, Cloud Machine Learning services to run energy forecasting ML models. Firestore was used to manage the connection between the dashboard and the Google Cloud Platform services. Now let's take a look at a demonstration of the functioning of our project.
So we first encounter the smart meter. From the smart meter, the main line gets connected to the distribution box. Here the main line is clamped to a current sensing device, a current transformer, which is connected to the load monitoring device. The load monitoring device non-intrusively measures the current using the current sensing device. So from the distribution box, the power is distributed among the household appliances. Here you can see our devices. Firstly, the power monitor is connected to the hair dryer, as you can see, and then we have the OTA socket, which is connected to the iron. And next, this is our AC controller. Now we'll look at a demonstration of our system. Now I'll switch on the iron which is connected to the OTA socket. As you can see, the iron is on. And next, let's switch on the hairdryer as well, which is connected to the power monitor. Now I'll switch on the AC. You can see the AC is on, and I will increase the temperature. The dashboard as well, you can see that the temperature is 20 and the AC is on.